welcome to Game Day from America Makes. I'm here with Agustin Diaz, and we're going to talk about finishing additive manufacturing parts, among other things, I'm sure.
Yeah. A little bit of everything, like additive manufacturing, different type of technology, and how we can do surface finishing of them for improving their mechanical properties, corrosion resistance, aesthetics, and all the cool stuff.
So what kind of, can you give maybe just a little overview for maybe those who aren't super familiar with what you're doing? Is it specific to an AM process or a material, or kind of what spectrum of things can you finish?
Yeah, that is an excellent question. When we start in the additive manufacturing world, we were coming from traditional manufacturing, so there were like relatively easy to erase machine lines and casting materials, removing lots like small defects here and there. When I arrived to REM, Surface Engineering, REM, we started looking into these additive manufacturing parts. They look super complicated, and there were many technologies coming into the game at that point, and mostly was electron beam. Electron beam was really big back in the days, and that's what we started doing a lot of research on EVM. Luckily, those were one of the most rougher parts that are produced in AM. So once we start developing for EVM, and then laser catch up, and then you have binder jetting, and you have filaments, all of that kind of like feel in line with we have developed. So it's quite agnostic to the process. So we can do basically any AM type of technology with our process, which is a chemical process too. So it's kind of geometry agnostic, at least the chemical polishing part. So you can immerse it in a bath, and you got all that chemistry touching all the surface at the same time. We can do some really good improvement in there.
Is it a talk maybe a little bit about volume, just so people can understand volume both in size and or in quantity. Is it a batching process where you're putting in 100 of similar or even different components?
Yes. That's an excellent question, because it's a chemical process, and this two steps to achieve like this pretty part. I have like two of cool parts that we process. One of them are made in filament. This one was made in binder jetting. It's a two-step. The first step is a chemical polishing process in which we erase the macro defects, and then the second step is a vibratory ball. So if you can imagine, I can have different sizes of bath to do one part, or 10 parts, or 100 parts, or just one really big component. And the same is going to happen with the vibratory balls. We have doing vibratory ball for over 60 years now. So we do really small component for like orthopedic screws and that kind of really small stuff. Or we can go all the way and do wind turbine gears, which is massive. So when we're moving into this realm, it's quite of an easy transition because we have the experience to work with that. But yeah, we can do like small batches, big batches. For example, this little baby, it's a collaboration that we did with HP. They wanted to send me like 5 of them. It's like, why 5? Send me 100. I can do 100 at the same time that I do 5. So it's cheaper, it's easier, it can be mass production, and this is binder jetting. So for them, it was easy to produce many of them at the same time.
So what is a typical reason, or maybe the prominent reason that people are finishing? Is it purely for aesthetics? Is it because in surface finish require, or is it to ultimately achieve a part performance that's required by application?
That's an excellent question, especially because it's my belief that many of the components that come out of the machine with the proper heat treatment, they're not going to need any surface finishing. It's just certain applications that are going to need it. And of course, we are still trying to implement all standards to new type of components, so they need to meet the usual 125, 64, 32 RAs, all those coming just from the machine lines and the type of surfaces that a machine produces. We don't have that for additive. It's something I'm working really hard to try to establish standard for additive and try to stay away from those. But many applications coming from those blueprints needs those surface textures, and that's going to be the bigger pusher. You print the component that you need to meet that specification for that specific type of application. Now you're going to find benefits out of that. The first one is sometimes part coming out of the printer come with particles attached to the surface that can be problematic. It can be something called foreign object debris, for aerospace type of applications that can be cleaned out and remove all of that. That's going to find benefits in the cleanliness. Also, when you do a surface finishing, your corrosion resistance, because you reduce surface roughness, improve. And then ultimately the mechanical performance. So the process that we do, I always push it towards optimal performance of mechanical properties, because I think that's the bigger need, like to go to those really high performances under high loads.
So I honestly don't know the answer to this because I'm familiar with the, I think, advantages, but not necessarily where it fits into the, value chain or maybe even workflow over the course of, I'm a parts manufacturer and I make 100 of these items, or maybe back up, I make a large component, because I'm thinking many things that we produce don't ultimately, you're not going to print and then ship. You're printing, you need heat treat, you need to machine, finish, seal surfaces, whatever it might be. Where does this process fit in, or does it depend? Do you process first and then I machine, or?
So there's different approaches that we can tackle that. I will always like to be introduced into the design phase, because it's additive manufacturing. You have the beauty of free form. You literally can design to surface finish and easily then remove those features, and then you can make the process a lot more easier and cheaper. You can make it super cheap just by thinking about the surface finishing even before printing, so in that design stage. Usually we come after an afterthought, which we can work with that, but it's painful, because many times we are going to miss that expectation from the customer. You
don't truly optimize the way we could, and then there's or there may be more time or cost, or there are, the capability is limited in some measure, which ultimately hinders additional adoption, which is something I wanted to kind of maybe close with, to just get a perspective from you. Where do you see so we're here sitting within Rapid Plus TCT right now, thousands of people coming through. How many people are familiar with finishing processes of their components? And you mentioned, ideally, we all want to design for additive, and we want to work on all of the things that we know can demonstrate its true capability and stop doing direct part replacement for things that don't make sense. But where do you think we're at right now? Like, if you were to say our status as a community.
We are a lot better than where we used to be. At the beginning, I remember getting customer asking me to remove just 5 microns out of a surface and make it perfect. It's like, you need to think about the powder size that you're working with is 50, so I cannot physically cut that particle and make that magic. I think that there is a lot of education out there. We're working really hard. Thanks to American Makes too. We are working with you guys and trying to illustrate to the community and to the whole consortiums like the benefits of surface finishing, that exist surface finishing benefits, that think about design. Also working a lot with NASA. I'm really active in the technical side. I have one book chapter out specifically talking about how to do surface texture characterization of these components, what to look for, how to optimize those surfaces to get the better finishing. But also with NASA, we work in another book chapter in collaboration with Paul Gradle and his co-worker on how to apply those surfaces. This is the application of those parts. There is a new book chapter coming this year that also working on all the possible surface finishing options there are for additive manufacturing, and which are going to be advantages and disadvantages of each one of these technologies, because I'm 100% believer that there is not a magic bullet here that you get a part and you use the same process over and over. That's not the case. There's many options, there are many tools, and I think we're a lot better. We're not where we're supposed to be, that everybody knows exactly the benefit of the surface finishing and what the surface finishing is, but it's getting there.
Yeah, I think overall it's maturing. I think one of the things that's exciting is when you look at what we have, just look around the showroom floor, there are more folks who are here to talk about something other than a machine can produce something.
Yeah.
There's acknowledgement, and I think a increasing understanding that it's a piece in the overall value proposition that is making components that somebody needs for some industry sector.
Yes.
And we're overall maturing. I think this is a piece of that puzzle that needs to continue to grow.
Yeah. I think the field right now that is embracing this really hard and really getting it is the space industry. They're doing a lot of really complex engine components, just internal parts, but also the actual engine nozzles, combustion chambers, and they are seeing the benefits of the surface finishing, the cleanliness, removing powder from those internal channels, getting those hot walls to a really specific thickness to get that optimal heat exchange between that hot wall and the cooling channels. The fuel system, there's fuel injectors, how they can manipulate the geometry doing surface finishing into it, and those flows, and it's getting super exciting.
That's an exciting piece of, they're a community that is either somewhat clean sheet working on designs, or they've seen real world successes in optimization through additive that is ultimately enabled by additive. It started creating those use cases that I think we're understanding now. It might be the only way we do ... moving forward. And we just need more use cases. So certainly appreciate all of your help over the years and engagement. I think in helping raise awareness on this topic. First and foremost, you're out very actively promoting the technology, but again, just helping us all understand what is possible and then helping us move forward as a community. So appreciate it.
Thank you for having us.
Absolutely. Thanks, sir.
Thank you. And cut.
Did it.